Alright, so you're going to notice that there really isn't much difference in doing a substitution problem with a definite integral. There's going to be one little thing. So we already did a problem like this a second ago, so what do we know the u is? Tangent. So we're going to write down our u as tangent of x. And we know it's going to work because its derivative is sitting here multiplied by the rest of the function. So here's what you're going to do. You're going to come over here. Once you figure out your u, you're going to substitute it into the problem. Here's what the issue is. If this says x, then what do you think these values are? X's. And now we're going to change them to u's. So what do you have to change these into? U values. So you're going to come over here, you're going to take your substitution, tangent of x, and you're physically going to use it on your limits. So I'm going to change the pi over 4, which is an x value, into a u value by using the physical substitution you wrote down. So tangent of pi over 4, that's an easy one. That's just 1. Sine and cosine are the same value. U of 0, another easy one, 0. That's pretty much the only major difference you have. That's it. Because the rest of the problem is going to look the same as what you've been used to. First thing we would do, find our derivative with respect to x, which you already told me was our secant squared x. Right? JP, what should I do after that? Multiply by, what do you want to get by itself? The dx. So I'm going to multiply by the dx. That's what I was hoping you were thinking. I'm going to say you were thinking that. I'm going to give you that. Alright. So there's my dx all by itself. So then now I'm going to just rewrite my problem. So my problem originally was from 0 to pi over 4, but we changed it. Now we're 0 to 1 because I need u values. The problem had tangent of x, but we changed it. We want that to be u. The problem had secant squared. Some of you might be getting good at this where you don't need to write down the full substitution. You kind of do a little bit of canceling in your mind. I'm still going to write down everything. I'm going to stick with the way that I've taught it. If you're getting better at it and you can skip a step, that's fine. Just be careful, please. So that means that now I get the integral from 0 to 1 of u du. This says u, this says u, that's a u, that's a u. You get to do the problem just like that. You don't have to ever substitute back in again. A lot nicer, right? These are all u values, correct? So now you do the problem in terms of u. So what's my antiderivative? Antiderivative. 1/2 u squared. Alright. Or you have u squared over 2. I don't really care. Alright. F of 1 is 1/2. F of 0 is 0. So step 1, 2, 3. Therefore our final answer, which I'm going to squeeze underneath here, would be 1/2 minus 0. So my total answer is 1/2. Meaning, if I graphed this horrendous looking function and found the net signed area from 0 to pi over 4, it will physically be 1/2, even though these are all u's. Okay? So the whole point of a substitution is that you take something that's really ugly, has product, has quotient, has chains, and you simplify it into something that doesn't have extra rules. That's why this looks so nice. But the fact of a definite integral, if you have limits that are x values, and you're going to do a substitution into u's, then you got to change everything to u's. That means your limits have to physically change. Okay? Are we good on the process? Alright? Please don't forget to do that. You'll essentially get a whole crap load of multiple choice questions wrong by doing that. Okay? Yes? Because then I'd have x's mixed with u's mixed with u's. So no, I don't want to substitute tan x back in, because then I'll have x, I'll have u, I'll have u, I'll have u. They're mixed. If you really wanted to, I guess you could have really kept these values, substitute back in at the end. I'd like making it simple. Does that make sense? Okay. So let's go to the next one. This one I think the value ends up being not as nice, but same concept. We're looking at the problem. What do you think your u is going to be? X cubed plus 1. You're going to do the entire inside. Just like when you do numerators, denominators, you tend to do the entire. Alright, so I know I'm going to take a derivative. Before I do that, I'm coming over here. I want to change my limits. I do that right away so I don't forget. So 1 cubed plus 1, 2, and just to save a little space, I'm going to do u of negative 1 here. Negative 1 cubed, negative 1, thank goodness. Negative 1 plus 1 makes 0. You're going to love the zeros, okay? Because when you do f of a, it's always 0. Alright, let's go back to where I was a second ago. Take its derivative. 3x squared. We can see that the 3x squared is even sitting in there. The whole entire thing is perfectly there. So, we're on the right track. Okay, so what do we get now? We get the integral from 0 to 1 of 3x squared multiplied by the square root of u multiplied by, oh, the 2, sorry, 2, multiplied by du over 3x squared. And then if you did it right, you should be canceling your 3x squared. Some of you probably are starting to figure out that you don't always have to write this little step here. Okay, so I'm going to rewrite it a little bit nicer. Alright, integral from 0 to 2 of u to the 1/2 du. Much nicer. Now it's just a quick power. So, double check that you changed your limits. They're not the same as before. You did your substitution. And now I can do my simple power rule. Alright, Ellen, what's my antiderivative? Let's start with the power. Start with the power. What do I do to it? 3/2. And then multiply by 2/3. Perfect. Alright, so there's my antiderivative. And then I'm going to put in my values. Let's put in f of b, which is 2. I get 2/3 times. When you do the 2, please start with the denominator of your exponent. So that's the root of 2. And then you're going to do root of 2 times root of 2 times root of 2. 2 root 2. Are we good? We sure we're good? And then T-Mon, what do I get for f of a? F of a? 0. Makes the problem nice and easy. I'm going to come back up to the top. I'm going to write in my value. So f of b minus f of a, my final answer is 4 square root of 2 of 3. Why wouldn't it be, what, one more time? 3 root 2? Alright, let's go through and look at that. You're good with the 2/3, Danny? So then you're just confused on this value. So I'm going to take 2 to the 3/2. So the half part, you understand what that means? Okay, so that's root 2. But then I'm going to take it to the 3rd power. So the other way I could write it is the root of 8. That would be correct also, but I want to simplify it. So that's one way, because 2 cubed is 8, then take the root of it. Then the other way you could look at it, and I'm running out of space, would be root of 2 cubed is the same thing as root of 2 times root of 2 times root of 2. Root 2 times root 2 makes positive 2. And then multiply by another root 2. Good? Okay. Alright, so on your next page, you got one that looks, this is the reason why I teach it in a certain way. The AP tests, they're not going to tell you what type of integration to do unless it's this type of problem. They don't finish it. They don't actually get down to the 1/2 answer. They don't get down to the number. What they do is they want you to do the substitution and not finish the problem. They want you to figure out what it looks like in between. And therefore, if you don't do it in a certain method, then you can't get this question right. So let's take a look at it. They want me to do u equals x over 2. They're telling me what u is, and I don't have to worry about checking it. I know I'm going to change my limits right away. So I know that I'm going to try to find u of 4, and I'm going to try and find u of 2, and then I'm going to have you guys kind of work through and try to figure out what you think the answer is, and we'll go over it. And I'm going to... Something looks funny in this problem. So what was u of 4? 2. What's u of 2? 1. So you go through, let's finish up the du dx is equal to, so you can't forget about the rest of that process. Du dx is equal to 1/2. Move that over and I get this guy. And then so now I'm going to finally do the substitution, which is where you should notice something weird happens. Alright, so we get integral from 1 to 2 of 1 minus u squared over x, and dx is 2 du. You notice something? X is in the bottom. Did we do it right? Did I know the u's right because they told me what it was. Right? So I have to use it. So there can't be that I did something wrong. There must be more to do. Is there a way to substitute out the x? Yes. So you're going to go back to your u. And we now know that u can be changed, that statement can be changed to x is equal to 2u. So now I'm going to rewrite it one more time. Over x, which is 2u, times 2 du. Does that answer show up? So what I would do in these types of problems, right away, when I change my limits, I cross out the ones that I know can't be the answer. I just quickly do that so I don't get, kind of blinded by them. The other thing I don't do, I don't guess. Please don't look at one problem and say, oh, this must be what happens all the time. Don't guess. You know how to do the problem. Start with the fact that you know the limits have to change those over, and then from that point forward, you follow the same process. Please don't guess on what you think always happens. All right, any questions? We sure? I want to give you, I'm pretty sure you guys can figure that part out.